All right, so let's get some practice applying the compound interest formula. So in this example, we're actually going to compare what happens under different, with the different number of conversion periods. All right, so we're supposed to find the accumulated amount after 3 years if $1,000 is invested at 4% per year. All right, so the principal is going to be $1,000. That's the amount we're starting out with. The interest rate is, the nominal interest is 0.04, so 4% per year. And then the t is equal to 3 years. All right. The only thing that's changing in all of these examples is just the number of conversion periods per year. So in this first example, compounded annually, right, we just have one compounding period per year. So m is equal to 1. All right, so let's, now we have all the numbers we need to plug in our formula. So the accumulated amount is going to be the principal times 1 plus r over, right? So you have 0.04 over m, which is just 1, right? And then to the basically 1 times 3. So there's just going to be a total of 3 conversion periods over the 3 years because it's compounded annually. All right, we can put that into our calculators and get $1,124.86. All right, so let's see how we can get the same investment, the same interest rate, same term of the loan, 3 years. And the only thing that's changing now is that we're compounding semi-annually, right? So this is m equals 2 periods per year. So we want to calculate that accumulated amount. How does that compare? We're going to kind of see how, does it make us more money? So you would think, maybe? If we compound it more frequently, maybe we'll make more money. So it's the same 4%, but with them out, whoops, 4%. 4%, but we have to divide by 2, right? Because that's the annual interest rate. And we have to divide by 2 because we have 2 periods, 2 compounding periods or 2 conversion periods per year. All right. Now, how many total conversion periods are there over 3 years if we're compounding semi-annually? Well, we're just going to take 2 times 3. So 2 per year times 3 gives us a total of 6 conversion periods over the term of this investment. All right. Then it's just a matter of putting in your calculator, right? So we have $1,126.16 is what I got. All right. So you can see we earned a little bit more. Now this is a pretty good deal, right? With the first, with just annual compounding, we can calculate the interest, right? We interest earned. The interest earned was equal to, if I just subtract off the $1,000 principal, then we earned $124.86. Just by compounding annually. Compounding semi-annually, though, looks like we made a little bit more. Interest earned is just $126.16. So you earned a couple dollars more in interest over that 3-year period. All right, let's take a look at what happens when we compound quarterly. So again, the only thing changes is the number of conversion periods. So if we're compounding quarterly, then m is 4 periods per year. All right, so I'm just going to plug the values into our formula. The principal is $1,000. We have 1 plus the nominal interest rate of 0.04, but now we have to divide by 4 periods per year. And if we're compounding quarterly for 3 years, we have a total of 12 conversion periods over that 3-year time span. Okay, 3 times 4. All right, so if I put that into my calculator now, I got $1,126.83. Woohoo! I made a little bit more. So this time the interest earned is equal to 126.83. Okay, so we earned like 73 cents more That's not too bad. Okay. All right. Let's see what happens if we compound monthly. Are we going to make more? You would expect so. Let's see what happens. So the accumulated amount, so in this case, m is equal to 12. Compounded monthly, there's 12 months in a year. So m is 12. So let's use our formula. 1 plus the interest rate, 0.04, now divided by 12. But we've got more conversion periods, right? We got 12 months per year for 3 years is 36 conversion periods over the whole term. So let's put that into our calculator. We have $27.27. All right. So now our interest earned is $127, 127.27. Okay, so we made a little bit more. All right, let's go all out here. Let's just compound this thing daily and see what happens. Compounding it daily, what's going to happen? So now we have 365 days a year. M equals 365. So the amount that we accumulate is going to be the initial $1,000 investment plus 0.04 divided by 365 this time. But now we have 365 conversion periods per year for 3 years. Okay, so I'm just going to take 365 times 3 to get my exponent. Okay, so whatever that is. So I can just put this into my calculator. What do I get when I put that into my calculator? I get $1,127.49. So we upped, we've got over 10 times the number of conversion periods, but we didn't really make that much more money. Maybe, 22 cents more by doing that. So the interest earned in this case is equal to 127.49. Okay. All right. So you can see the more we convert, and the more we compound, more frequently we compound, the more we're going to make. But it's kind of diminishing returns. I mean, when we went from compounding annually to compounding semi-annually, we made a couple extra dollars. But we went from compounding monthly to compounding daily, and it's a few cents. So it seems like the more you convert, we kind of have some diminishing returns there. So here's just a summary of what we just calculated, so you can kind of see a comparison of how we're earning money. So, and of course that brings up a question. Well, what if we compounded more frequently? Well, is there a limit to how much we can make? So that's what I'm going to talk about in the next video. We're going to talk about continuous compounding of interest. So not just compounding quarterly or monthly or daily, but compounding continuously, like more than every second, more than every millisecond. We're just going to compound continuously. All right. So I'll meet you in the next video.